That day I had taught you about sets. Now today we are going to learn methods of writing sets. How to write sets. So we have got two methods of writing sets. One is listing method, or it is also called as roster method. The second method is as a rule method, or it is also called as set builder form. We have only two methods of writing sets. Now this first method, listing method or roster method. How to write in this method? Example. Example 1. Suppose set of natural numbers. Set of natural numbers. In the previous video, I already taught you how to write sets. So, here, when I talk about natural numbers, always the set name must be given with a capital letter N, natural numbers. You know that natural numbers are 1, 2, 3, 4, 5, 6 and so on. They are infinite, so we cannot write all the sets, all the elements. So these are the elements of the set of natural numbers. 1, 2, 3, 4, 5, 6, 7, 8 and show it with dotted. This indicates that natural numbers are infinite. So in this way, when we write all the elements, we show the list. Listing means we show the list of the elements in the set. So this is called as listing or the roster method. In this way, we write the set in listing method or the roster method. At the same time, now I am going to teach by the second method how we write the set. That is rule method or set builder form. Set builder form. Now, here example is already written. I shall not write the example. So here, when we write it in the set builder form or the rule method, we indicate it like this way. X is an element. X is an element such that X belongs to, this is belongs to symbol, X belongs to N as natural numbers and X is equal to, we give a comma here, this indicates and X is equal to 1, 2 and so on. Here in this one. So in this way we do not write the elements, only we give in words that X belongs to natural number, or we can show it in this form also. Yes. Now, second example. Set of even numbers. Set of even numbers. Set of even numbers. I'll name it as E. We know even numbers is 2, 4, 6, 8, 10 and so on. Again, it is infinite. So, we are showing the elements here. And it's infinite, so we cannot complete this. So, we leave it showing with dotted lines. Now, this only second example. This is first example shown by the rule method. Second example, when we write with the rule method or the set builder form, even numbers E is equal to as X is an element such that X belongs to, it is natural numbers only. Yes, but X is an even number. X is an even number. This way we write. We show it with words. We do not write the elements in the set rule method or set builder form. Third example. Set of odd numbers between 5 and 29. So, I will give it as any name. Suppose A. X is an element. Sorry. Set of odd numbers between 5 and 29. Between 5 and 29 when we talk, 5 is also an odd number. It's an odd number. And even 29 is also an odd number. But between these two, we have the elements as after 5, 7. Then 9 comes. So we have to write up to, before this we have got a 27. Therefore, from 7 to 27 only this many elements must be written. So, in the listing method or the roster form, we have the elements in this as 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27. This is the last element. So therefore we have got elements as here 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27. The same example when we write it as in the set builder form or the rule method. The third one, I have taken it as name as A. Here also I'll give it as A only. X is an element such that X belongs to natural numbers. It is natural number only. But X is an odd number. But X is greater. It is between number. So therefore we have to give it, see X is greater than, it is between 5 and 29. So it is X is greater than 5 but X is less than 29. For between numbers we have to write in this way. So X is an element, X belongs to natural number, but X is, give a comma here, X is an odd number, but as these elements in this set are between numbers, so therefore X is greater than 5 but less than 29. In this way we have to show. Now fourth example, set of prime numbers. Set of prime numbers. Now, prime numbers. So, let me take it as P. You know the first prime number is 2, 3, 5, 7, 11, 13, 17, 19 and so on. There are infinite prime numbers. We cannot write all the elements here. So in the listing or the roster form we write the elements and show. When the elements are unlimited then we write, show it with, ended with dotted form, dotted line. Now the same example when we write with the second method, that is rule method or the set builder form, then we will write it in this way. X is an element, X prime number. When we talk about prime number, it belongs to again natural numbers, but X here, X is a prime number in this case. We do not write the elements here, but we express it as showing in words. So X is an element, X, this slash shows, we have to read it like this way. X is an element such that X belongs to natural numbers and X is a prime number. So X is a prime number. When we talk that X is a prime number, then we know that the elements are 2, 3, 5, 7, 11, 13 and so on. Now some of few examples. Example 5, set of English alphabets. So English, E, L, name it as E, suppose. English alphabets A, B, C, D, E and so on, we know up to Z. This is listing method. The same method when we write in the set builder form, X is an element such that X is a letter of English alphabet. Of English alphabets. Alphabets. You can write in this. Okay. Then one more example. Again more examples. Set of positive integers. Between 8 and 22, suppose. So set of positive integers between 8 and 22. Now give it as name B, suppose. Between, we are talking about between numbers. Between 8 means after 8 only. Positive integers. So it will be 9, 10, 11, 12 and so on. Between the last one will be 21. Yes. Between 8 and 22. So the previous one, that is 21 with the last element here. So here when we write it in this method, X is an element such that X, it is positive integers means it belongs to natural numbers. Belongs to natural numbers. And X is, it is between number. X is greater than 8 but less than 22. Oh. Now, one more example. Set of divisors of 12. So we know the divisors are factors of 12. Yes? Suppose C. Factors. This 12 can be divided by 1, 2, 3, 4. Yes? 6. 6 2s are 12. 3 4s are 12. Then again 12. It can be divided by itself also. So 1, 2, 3, 4, 6 and 12 are what? Divisors of 12. So they become the elements of this set. Now seventh one, C is equal to, when we write it in the rule method, X is element such that X is a divisor of 12. I can write directly in this way. Yes. Now, 8th example. Set of multiples of 5. Now, suppose multiples. I'll name it as n. Multiples of 5. We know it is 5, 10, 15, 20, 25 and so on. Infinite elements are there. Now, same thing when we write it in this second method, m is equal to as x is an element such that x is equal to 5a. I'll give any other variable 5a. A indicates here or 5n. N where n is equal to 1, 2, 3, 4 and so on. Why we write it in this form? For multiples number, we will write it. Suppose multiples of 6 means we will write x is equal to 6n. Multiples of 10 means 10n. Why? Because see, if I multiply n is equal to 1, 2, 3, 4, 5, 6, they are natural numbers here. So if I multiply with 5, 5n means 5 into 1. 5 on the 5, 5 to the 10, 5 to the 50, 5 to the 20 and so on. It shows the elements of this set. So whenever we write multiple numbers, we have to write it in this form. Now some more examples. Example number 9. Set of letters in the word Maharashtra. When we write like this way, whenever particular word is given, we have to write the set letters of the set. So, set of letters. Therefore, we'll name it as, suppose, any name we can give, D. Set of letters in the word Maharashtra. You can see that some alphabets are repeated here. A is repeated 3 times. Yes? Now, H is also repeated. R is also repeated. Yes? So, therefore, we'll write it as Maharashtra. M comes. Yes? We can write it in capital letters also. Yes. A. Then comes H. R. S. H is repeated here. So, we will not write H again. T. R is repeated. A is repeated. So, we will not write. Yes. So, we write in this way. Therefore, now, with the second method when we write, in the rule method or set builder form, it is in this way. X is an element such that X is a letter in the word Maharashtra. In this way we write. Now, example 10. Set of squares. When we write square numbers, it is with little different type. So, set of squares. Now, I'll name it as, suppose, S. Squares, you know. 1 is square, 1, 2 square is 4, 3 square 9, 4 square 16, 5 square 25, 6 square is 36 and so on. Again, they are infinite numbers. So, again when we write this in the rule method or set builder form, this becomes little different way to write. So here again the same way, s is equal to x is an element such that x is equal to n square, where n is equal to 1, 2, 3 and so on. Square, 1 square is 1 only, 2 square is 4, 3 square is 9 and so on. So as it is infinite, so we show it with dotted lines. So square or cube numbers must be shown in this form. Now 11th question, set of cubes again. So set of cubes, see, 1 cube is 1 only, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125 and so on. Now, the same thing when we write it in the second method, here c is equal to x is an element such that x is equal to, again we can write in this form, is equal to n cube, where n is equal to 1, 2, 3 and so on. 12th one, set of cubes, set of squares between between 1 and 36, suppose. Now set of squares between 1 and 36. 1 and 36 means it will come from 4, 9, 16 and so on. So between numbers, it is squares. So 1 square I leave it, 2 square, 4, then it is 9, 16, 25, 36 is not written because it is between 1 and 36. So 4, 9, 16 and only 20. Only the 4 elements are there in this set. The same thing when we write in the second method, here d is equal to x is an element such that x is equal to n square, because they are square numbers. But n is what? N is greater than 1 but less than 36. In this way, we show it in the rule or set builder form.